Hello everyone. This video we will see theorem 1 Euclid's division lemma from page 38 in the 10th standard mathematics book of Samacheer, Kalvi. Now this is the theorem, but before we go into the theorem I want to give you an illustration and explain this theorem to you. So let's consider there are 34 cakes and these 34 cakes have to be packed in 5 cakes in one box. In each box there should be only 5 cakes. So how many boxes do we need? We would need 6 boxes because 5 times 6 will be 30. So let's take 6 boxes. So we have here 6 boxes and in each box we have 5 cakes. So after putting these 5 cakes in each box, how many cakes are we left with? We are left with 4 cakes. Great. So 34 is the total number of cakes and we put 5 inside of each box and there are a total of 6 boxes. So after putting all the 5 or 6 boxes with 5 cakes each, we are left with 4 cakes. Okay, let's write this as an expression of A, B, Q and R. So A is 34, B is 5, Q is 6, R is 4. R is the remainder. Now this remainder we know has to be less than 5. If this is 35, then what will happen? Your remainder will be 0 because then the 6 will become 7. So this remainder R will never be equal to this number 5 or this number B. So let's say that R has to be less than B and also R can be 0. When this is 35, there will be 7 here and your R will be 0. So R can be 0 and it can go all the way up to 4, which is less than B. Can be any number between 0 and less than B. So this is our condition here. R has to be greater than or equal to 0 and it has to be less than B. Okay, and also the relationship between A and B can be written as A has to be bigger than B. If you had 4 cakes, you cannot put 5 cakes in each box. So this 34 has to be bigger than this 5. So A has to be bigger than B. So that's our second condition. A has to be bigger than B or A is greater than B. And if our R is equal to 0, what happens? It becomes A is equal to BQ and R will vanish. So we can say that if R is 0, A is equal to BQ. Okay, and this A is our dividend here, B is the divisor here, Q is the quotient here, R is the remainder here. Alright, let me see if you remember what we have learned. Do you remember this expression here? Good. It's A is equal to BQ plus R. Okay. Now let's see if you remember the condition for R. I'm going to give you a second. Yes. R has to be less than B and R has to be greater than or equal to 0. And the relationship between A and B are? Good. A has to be bigger than B. Okay, and the last condition, if R is 0, what happens to this expression? Good. A will be equal to BQ. Alright, so now we can write this expression in a very generalized form where we say A and B are 2 integers. Okay, we're talking about these 2 integers here, A and B. Then there exists unique integers Q and R. So there are 2 other integers Q and R such that A is equal to BQ plus R and our R has to be greater than or equal to 0 and R has to be less than mod B. When we say mod B, R cannot be a negative number, it should always be a positive number. So this is the condition of R in the Euclid's division lemma. Alright, so now let's go on and let's try and do some problems. Let's do our example 2.2 to understand this better. So we have the first one as a is equal to minus 12 and b is 5. So we need to write this as an expression in terms of Euclid's division lemma, which is a is equal to BQ plus R. Okay, so let's take the first one. So in the first one, a is equal to minus 12 and our b is 5. All right, so let's try and find our q and r. So let's divide this a minus 12 with b, which is 5. So with our division rule, we know we can say minus 2 here, so you will get minus 10. So subtracting these two, you will get minus 12 plus 10, which will be minus 2. But we know that our r cannot be less than 0. Here is r is less than 0. So let's try and work out once again. So now this time, instead of 2, let's put 3 here. So 5 3s are 15. So it's minus 15. Subtracting minus 12 with minus 15, it becomes plus. So you get 15 minus 12 as 3. Great. So this is our R and that's our Q. Let's write this expression now in terms of A, B, Q and R. So minus 12 is equal to 5 times our Q is minus 3 and our R is 3. Right, let's try the second one now. Our A is 17 and B is minus 13. So let's do the same thing. 17, sorry, it's 3 minus 3. So 5 3s are 15. So minus 15. So you get 2 as your remainder. And this is our Q. So we can write this expression as 17 is equal to minus 3 times 5 plus 2. Let's do our last one. Or A is equal to minus 19, B is equal to minus 4. So dividing minus 19 by minus 4, you will get 5 times minus 4 to be 20, minus 20. So minus and minus will become plus here. So 20 minus 19 is 1. So our R is 1 and our Q is 5. So let's write this expression in the A, B, Q, R form. Minus 19 is equal to minus 4 times 5 plus 1. Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.